Hello, it's Mr. Avan again, here on our second week away from school. Yay! Ooh. It's kind of a mixed blessing, isn't it? You get to stay home, no school, but at the same time you miss school. You miss doing the things with your friends, even though you had to do all that work. Well, now it's even tougher because there's no one to hold your hand and help you do this work. Except I'm here on these videos to try to help you with some of the last bit of math that we were learning in 4th grade. It's very important. I know there's only a few of you. Some of you have been trickling in. I have Wa, I know Isabella's been doing the work. Jonathan Blanca has been checking in. I've heard from Tiffany, and I've also heard from Carly Dunn. So there's a few of you out there who are doing the work. I can tell by my views on YouTube that there's not too many of you. But guys, you've got to do some math. There's no telling what the future's going to bring or when we'll be back in school. Right now we're still saying we're going to be back on April 13th, but that may change depending on what happens on the national level and what happens here in Baton Rouge. It looks like Louisiana is going to have a surge in people who are testing or being tested and have the virus. They're just not sick. But the real danger, of course, is that your grandparents, the older people, can get sick and die from that. That's where most of our deaths are going to come from, is from older people. So that's why we're staying separated. That's why we are not going out and going to movies and things like that, so we don't spread the virus that some of us may already have. In the meantime, though, we've got to make sure we know our math. This 4th grade math is really basic stuff that you need to know as an adult. So eventually you will go to 5th grade. And without this work right now, 5th grade math is going to be really hard for you. And if you don't do the work now, it may keep you from going to a better middle school. That's what you should all be shooting for a really good magnet middle school that you can get into. Alright, let's begin the magic. Today we are going to be taking those mixed numbers and turning them into improper fractions, and we're going to be turning improper fractions into mixed numbers. Module 5, lesson 23, lesson 24, or it could be 24, 25, I'm not sure. But when I get up on the whiteboard, I'll let you know. I'm going to show you how I like to do it. I'm going to give you 2 or 3 different ways of doing it. I'm going to show you how Eureka does it. But keep in mind, you need to understand how it works. Fractions are division, and your quotient, or the answer to a division problem, is your whole number and a mixed number, and your remainder is the numerator, and your dividend is going to be your denominator. So let's find some more out about it. Presto, here we go. Okay, I'm back. Let's look at the whiteboard. Okay, what I've decided to do is go ahead and we're going to include lesson 23 in our discussion. That's 23, 24, and 25. Let me adjust the light a little bit. Okay, this is what's going on in Eureka, and this is what we're trying to learn. Fractions as multiplication and division is basically what I'm calling this. Again, we're trying to turn mixed numbers into improper fractions and improper fractions back to mixed numbers. You're going to see this on the LEAD test a lot. Maybe not this year, but definitely next year you're going to see this on tests. Alright, let's look at lesson 23. If you've been looking in your book at the problem set for lesson 23 and the Eureka videos put out by Embark with Mr. Hallbecker, you'll see him doing something with the number line up here. We're going back to that same thing we did at the very beginning of fractions. We talked about unit fractions times a whole number. Okay, in this case, our fraction is 1/2, and we're multiplying by 10. Remember what happens when you multiply a whole number times a fraction. You're multiplying the whole number times the numerator, which is basically 10 over 1 times 1/2. So that's 10 times 1, 1 times 2, that equals 10 over 2. Let's look at it on the number line. This is a way of showing multiplication and division. So we're going to number this 0, 1, 2, 3, 4, 5 whole numbers. It's divided into halves. So I'll divide each one into half. Now, the easy way to do this is to count the number of halves. We can do that by jumping as well. So we'll do 1/2, that's 1, 2, 3, that's 3 halves, which is 1 1/2, see 1 1/2, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, and 10 halves. We land right here on the whole number 5. Remember, each one of these is 1/2 jump. Okay, by skipping by 1/2 and counting up all our halves, we get 10 halves. If you look at the number line, we have 5. Or what I'm trying to tell you, if we divide 10 divided by 2, we get 5. That's all lesson 23 is trying to do for you. Alright, that is lesson 23. This problem is 3B, page 119. That's how it's done. Okay, let's move on to lesson 24, page 122, number 2C. I think that's on a homework page. 17/4. Now what they're trying to say is, look at where 17/4 is on the number line, figure out how many whole numbers have jumped there, and then count your remainder left over, just like we would on a division problem. I'm going to show you that on the next video. So, we're going to divide this into 4. So, let's start off by naming our whole numbers. 0, 1, 2, 3, 4, 5. Okay? Then we divide them into 4ths by making 3 lines. Or 3 hash marks in between gives us 4 equal parts. Okay? So we divided our number line into quarters. Let's count where 17/4 is. Here we go. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, 12/4, 13/4, 14/4, 15/4, 16/4, and 17/4 lands right here. Now what they're showing you on lesson 24 with this number line is if when you make this one big jump, you find your first whole number. And I land on 4. Therefore, 4 is our whole number in this mixed number. Okay? Then you figure out how many more 4ths do you have left over. Well, there is 1/4 left over here. So I make that little jump, and there's my 1/4. So 17/4 is equal to 4 and 1/4. Okay? Very simple. Very simple. I'm going to make it even more simple later on. Alright, when we get to lesson 25, let me get my blue. We're on page 125, problem set 1C. We have a mixed number that is 3 5/8. So let me start off by making my number line here. I have 0, 1, 2, 3, and 4. I think that's as far as I need to go. Right, because it says 5/8. Now, these are broken up into 8ths. Look at the denominator for your fraction here. We're dealing with 8ths. So that means I have to make 7 marks in between each fraction to create 8 equal parts. So that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That gives me 8 equal parts in between each one. Alright, now let's find the whole number 3. So I'll make that jump all the way over here. Or, here's what else they were showing you. You could go ahead and count how many 8s are before you get to 3. How many 8s are there in 3 whole numbers? Right? Let's figure that out. So if I make one jump here, how many 8s is that? Remember, one whole number equals 8 over 8 here. So that's 8 over 8. I'll make another jump. That is another 8 over 8. Put a plus sign here. I'll make another jump. This is where we're supposed to end. That's another 8 over 8. Plus sign. And then it says I have 5 more 8s. 1, 2, 3, 4, 5. So I'm going to stop right there and make my other jump. That's 5 8s. So right here is 3 and 5 8s more. Let's figure out how many 8s we have altogether to get it to our improper fraction. By the way, in Eureka, they are calling it something different. They're not calling it improper fractions. They are calling it a fraction greater than 1. It's the same thing as improper fraction. Don't forget about that. Okay, let's add these up. I have 1 8, 2 times 8, 3 times 8. What's 3 times 8? 24. So if I put all these together right here, so 8 8s plus 8 8s plus 8 8s plus 5 8s. So we say that's 8 plus 8 plus 8 is 8 times 3 is 24. 24 plus 5 is 29. I have to put it back over the 8. Therefore, 3 and 5 8s equals 29 8s. Now, that's that. Now, on the next video, I'm going to show you how to do this in a much easier way. You can still use the number lines to help you out, but I'm going to show you a technique where you don't have to do the number line. It's just a matter of division. Now, most of your problems you're going to see in 4th grade are not going to be hard fractions to divide. Let's do that next. Boop. Okay, I'm back. Another sip of coffee. All right, let's take a look here. Like I told you, I'm going to try to show you how I like to do it. This is called converting mixed numbers to improper fractions. Again, Eureka calls it fractions greater than 1 because remember, a fraction is represented as a whole number until the numerator is the same as the denominator. Then once it gets bigger on the top, it's greater than 1. We have always called it improper fractions. You're going to see it called improper fractions again, so make sure you know what both of those mean. And reverse, meaning changing improper fractions into mixed numbers. So, again, lesson 24. We're going to go back to lesson 24 on page 124. We're going to look at example 3e. We are turning this improper fraction, numerator is much bigger than the denominator, and we're going to turn it into a mixed number, but we're not going to use the repeated multiplication or addition or the number line to show you this. We're simply going to stick with quick division, mental division, and quick multiplication. And when we get to lesson 25, I'll show you another trick for going the other way. All right, let me get my blue marker. And we're dealing with 23 over 7. So right off the bat, what I want you to think about is this denominator. It's a 7. We're in sevenths. What you need to know here, as soon as you see that bottom number, you think, bam, I need to know my multiples of 7. So let's do that. Just like with division, we need to know what the multiples of 7 are to help us out with a division problem. So what are the multiples of 7? Let's start with 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. And 7 times 4 is what? 28. Okay? Now, I see that the top number is somewhere between 3 times 7 and 4 times 7. That's going to help us out. We can stop our list right there. So, we can do this a couple of different ways. I can show you like this. 23 divided by 7. And remember, the 7 stays the same on the bottom. 23 divided by 7, I can look at it this way. I know that 23 divided by 7, I need to do 7 times 3. You see that third multiple right here? This is 7 times 3. That means our whole number is going to be 3. So, I put a 3 here, and now I need to know the remainder. What is 21 minus 23? Well, 21 minus 23 is 2. That means there is 2, and then I'm going to come over here and grab my denominator again and put it over 7. You can look at it that way. Or, again, you're just looking at the answer to a division problem. 23 divided by 7 is 3 with a remainder of 2/7. Let me show you that in a division problem. Let me set up the long division. Here is a long division problem here. We said that the 7 is our divisor, the denominator is a divisor. Let me get a different color. Let me use red. Okay. Alright. This, the denominator, is our divisor, and our dividend, let me get rid of this, our dividend is the numerator, 23. Okay? See, it's a division problem. 23 divided by 7. Now we said this division question up here, does McDonald's sell cheeseburgers? The division question is, how many sets of 7 can I find in 23? Well, looking at our multiples, we can see we can find 3 sets of 7 in 23. And so I'll put a 3 on top. And then I'll multiply. Next step, does McDonald's multiply? 3 times 7 is 21. And I want to subtract. 3 times 7 is 21. I check. Well, I haven't subtracted yet. I subtract. I get 2 left over. I check. The 2 is less than the 7. I don't have anything left to bring down. Therefore, this is my remainder. The remainder is 2 7s. You see that? 3 and 2 7s. 3 and 2 7s. So, I've given you 3 different ways to do this today. 1 using the number line, 2 using mental division, and the 3rd way using your long division and finding that remainder. Alright, let's move on to lesson 25 and do the reverse. We're going to start off with a mixed number, and we're going to change that into an improper fraction, or a fraction that is greater than 1. Here we go. This is the easiest way in the world to do this. You're going to love this. It works like a clock. Okay? The direction is clockwise, meaning that everything spins this way. Think of it as a clock going around this way. So what we're doing is we start off by multiplying. You multiply 8 times 4. You start here. You start by saying 8 times 4 equals 8 times 4 equals 32. See how we're moving around this way? And then the next part is we add 32 plus 3. So it's multiply, add over the denominator. So multiply 32, we add 3, the numerator, and we get 35, and we put it back over the denominator, 35/8. You see how easy that is? Like a clock this way. 8 times 4 equals 32, plus the numerator plus 3 equals 35, back over the denominator. Multiply, add over the denominator. Don't forget, I'm going to show you on the Eureka book in just a minute. Boop. Bye. Okay, here we are again. We're back on our module book. I am in lesson 24, problem set, and we're on page 122. You'll have to please excuse my hands. I've been working outside a lot and they're all beat up. So I don't have the nice teacher hands anymore. They're getting kind of roughed up. But ignore my fingers and focus on our math. We're going to start with the easiest one. Remember, when we're going from improper fractions to a mixed number, we want to think about division. So again, I like to make my fraction bigger so you can see it. This is 9/4. We're trying to get to a whole number or a number that is bigger than 1. So with fourths, remember 4 over 4 equals 1. What does this equal as a mixed number? How many whole numbers are in 9 in fourths? How many sets of 4 are there in 9? What is going to help you here is that multiple list. So 1 times 4 is 4, 2 times 4 is 8, and 3 times 4 is 12. We want to go with the multiple that is less, just like when we're dividing, that is a little bit less than the number in our multiple list. So in this case, the second multiple, 2 times 4 is 8. So I'll write that down. 2 times 4 is 8. 2 is equal to 8 fourths. How many more fourths do I need to get to 9 fourths? Well, I just need one more fourth. So it's 2 and 1/4. Let's look at it as a long division problem. We're dividing 4 into 9. Look at this simple division problem. How many sets of 4 are there in 9? Well, that is 2. 2 times 4 is 8. 8 minus 9 is 1. So 1/4. You see the remainder right there? 2 and 1/4. Let's do another one. Let's look at B, 17 fifths. Again, you want to get a multiple list. Let me make this bigger, 17 fifths. Let's make a multiple list. 5, 10, 15, 20. We got to stop there because it's much bigger than 17. 15 is going to be the perfect one. That is the third multiple of 5. That's 3 times 5 equals 15. Therefore, I know my whole number is a 3. Okay? Now, let's point you back up here again. 3 times 5 is 15. That is 15 fifths. How many more do I have left over? I have 17 fifths. How many more do I, from 15 fifths to 17 fifths? Well, there's just 2 more. 2 fifths plus 15 fifths equals 17 fifths. Therefore, that is 3 and 2 fifths. Let's look at it as division. 17 divided by 5. How many sets of 5 are there in 17? There are 3. 3 times 5 is 15. 15 minus 17 is 2. There is your fraction. 2 fifths. Remember that bottom number always stays the same. Let's do one of these big ones up here. Look at this big one, 48 ninths. How are we going to do that? I know some of you get intimidated by the larger numbers, but you shouldn't be, as long as you know your multiples of 9. That's why I kept telling you how to do your times tables, so you know this automatically. Let's make a multiple list anyway. 9, 18. What is the third multiple? 3 times 9 is 27. 4 times 9 is 36. And 5 times 9 is 45. Ooh, we got to go up one more. 6 times 9 is 54. 54 is too big. 45 is just right. That is, what? 5 times 9. Okay? So I know that the 5 is my whole number. So 48 over 9 equals 5 whole numbers. And how many more ninths? Well, again, you know that 5 whole numbers is equal to how many ninths? 45 ninths. So we have 45 ninths plus how many more ninths equals 48 ninths. Well, I know that I need 3 more to get to 48, so our remainder is 3 ninths. So 5 and 3 ninths is my answer. Let's look at it as a division problem. 48 divided by 9. How many sets of 9 are there in 48? Well, there's at least 5 whole sets. 5 times 9 is 45. 45 minus 48 is 3. So there's our 3 ninths right there. Okay? Keep practicing this. Do the homework. and check your work against the homework solutions that you'll find on Google Classroom. Let's move over to the same type of homework set. This time, problem set. I love these little problem sets here. This is lesson 25, page 126, and we're looking at these boxes of mixed numbers, and we want to turn them into fractions greater than 1. Remember, I like to call them improper fractions. Stay down. Okay, improper fractions. Okay, let's look at A, and then we'll try to do one of the hardest ones here. Remember that trick I showed you? Clockwise, you're going to spin around in a circle like this. You're going to go in this direction. Let's write it bigger. 2 3/4. So I'm going around this way. Beep, 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 beep. Going around that way in a circle this way. It's 2 times 4 plus 3 back over the denominator. So let me write that out. 2 times 4 plus 3 equals back over the denominator. And I'll even do that too. I'll put it over the denominator like this. We're dealing in fourths. Okay, so 2 times 4, do the parentheses first, is 8 plus 3 over 4, and that's going to equal 8 plus 3 equals 11/4. So, what are we saying here? We are saying that there are 2 sets of 4s plus 3 more 4s, or we're saying that 2 whole numbers, which is 4/4 plus 4/4 plus 3/4 more, equals 11/4. You can break it up that way too. Let's look at it that way. 2 sets of 4s, so that's 4/4 plus 4/4. That is equal to 2 plus 3/4 more. So 4 plus 4 is 8. 8 plus 3 is 11/4. Okay? A couple of different ways to look at it. Alright, let's go to a bigger one. I did F for you on the board already. Let's look at C here. Okay? C says 3 3/6. Alright, let's do that first trick I showed you last there. Okay, 3 whole numbers and 6 is 6/6. So I need 3 6/6s. Okay, that's 3 whole numbers and 6 plus 3/6 more. So that's 6 plus 6 is 12. 12 plus 6 is 18. Or we could say 3 times 6 is 18 plus 3 more is 21/6. Let's do our other trick here. Remember, we go in a circle like this. 3 times 6 plus 3 back over 6. So that would look like this. 3 times 6 plus 3/6. So that's 18 plus 3/6. And that is equal to 21/6. It's so easy. Even Boss Baby could do this. My little girl's watching Boss Baby now. Okay, let's do this last one. 3i. Let's see. Let's do it fast now. 10 times 7 is 70 plus 3 equals 73 back over the denominator. See how quick that is? Look at this one. 4 3/8. 8 times 4 is 32 plus 3 is 35/8. Once you get quick, it's no problem. That's how quick it should be. Alright, good luck on this stuff. Practice on the homework, and I'll be seeing you again in a couple of days. Peace and love. Boop.